We want to find an equation for the line in the graph below. When I think about equations of lines, I typically think of the slope-intercept form. The complication in this example is that the y-intercept for this graph does not fall on a tick mark, and I don't want to make any assumptions about points that don't fall nicely on the grid. So while I would typically prefer to use the slope-intercept form to state the equation of a line, this is an example where the point-slope form will become advantageous. Whether I'm trying to find the slope-intercept form or the point-slope form, the first thing I do need to do is I need to find the slope. Since I do have a graph in front of me, I'm going to find this slope by finding 2 points on the line and counting the rise compared to the run between those 2 points. There are actually 4 points here that would be convenient to work with, because there's 4 points that fall onto the grid. There's a point at -10, -3, -4, -1, 2, 1, and 8, 3. I will choose to use the 2 points over in the first quadrant, 2, 1, and 8, 3. Starting at the point 2, 1, I see I need to move over 3 tick marks to get to an x value that's used by the point 8, 3. What I need to recognize is that while I moved over 3 tick marks, the spacing of these tick marks was actually 2 units apart. So my run in this particular case is actually 6. To now move up, I need to move up 2 tick marks, but looking over the y-axis, I see that the scale there is 1, 2, 3, so moving up 2 tick marks really is moving up 2 units. So now we know that the slope is the rise over the run, which in this case is 2 units up and 6 units to the right, 2 over 6. I'll reduce that fraction to give me a slope of 1/3. Now that we have the slope, we can state the equation in point-slope form. We want to remind ourselves point-slope form is y minus y1 equals m times x minus x1. We've already calculated the slope by counting that out. The other thing we need to substitute into the point-slope form is one ordered pair, x1, y1. Now we can pick any point that we know, so we could state this answer in point-slope form using the point 2, 1. If we were to do that, our equation would become y minus the y value of 1 equals the slope of 1/3 in parentheses x minus the x value of 2. But just as correctly, we could have also used the point 8, 3. Had we stated it using the point 8, 3, another correct answer would have been y minus that y value of 3 equals 1/3 the slope in parentheses x minus that x value of 8. Both of these answers, y minus 1 equals 1/3 quantity x minus 2, and y minus 3 equals 1/3 quantity x minus 8, are correct. Actually, because there were 4 separate points that we knew from the line based on the graph, there were 4 correct answers we could have given for this particular equation. All of them would have earned full credit, and no equation is any better than any of the others. A key idea in this example is that I would not have used the slope-intercept form to state this answer. Because the y-intercept was not clear from the graph, it would have taken more effort to try to use that form.